This video is just a brief review of prime factorization. It's a really valuable skill that you're going to need to have for Chapter 5 of Pre-Calc 11. So if you know how to prime factorize and you're really comfortable with it, feel free to skip this. But if it's something you don't remember because you might not have done it since grade 10, maybe even grade 8, take a quick look at this video, go through things, just make sure you understand everything that's going on. So, to set the stage for prime factorization, need to go over a few quick concepts. First, prime number. So what is a prime number? So you hopefully recognize this term. A prime number is any number that's only divisible by two things, specifically two things. So it has to be divisible by itself and by 1. And so prime numbers are things like 2, 3, 5, 7, 11, and so on and so on. And what's a factor? So factors are things that divide into other things. Think back to factoring, where we were doing common factors and just factors in general. And so prime factorization, not surprisingly, is going to combine these two things together. So just as a quick example, the factors of, let's say, 24 are 1, 2, 3, 4, 6, 8, 12, and 24, because these are all the things that you can divide 24 by cleanly. So prime numbers and factors, if you put them together, you get what we call prime factors. And that's not a complicated concept. It's just a factor that is a prime number. So if you look at 24 and all of its factors there, its prime factors are just 2 and 3. 1, by the way, is not considered a prime number, so the only prime factors there are 2 and 3. And so bringing all of this together, prime factorization, the topic of this quick little review, is taking a number, like 24 or really any number, and breaking it down, but specifically breaking it down into a bunch of prime factors. And it's a bunch of prime factors that are multiplied together, so we're going to say it's into a product of prime factors. So, for example, 6 is just 2 times 3, right? So those are the prime factors of 6, and we just multiply them and we get 6. 12, you might say is, well, okay, it's 2 times 6, but 6 isn't a prime number. It's 3 times 4, but 4 is also not a prime number, but it's 2 times 3. So this 2 times 3 here, that was just 6, and so it's just 6 with another 2 on it. 30, same idea, is 6 times 5, and so if 6 is 2 times 3, that's just 2 times 3 times 5. And we could go on and on. Most of the time we're going to be dealing with slightly more complicated numbers than this, though, so we need strategies to be able to break down and work with something bigger. Say, for example, 480. So some of you watching this could probably eventually, if you sat there and tried really hard to get through things and keep track of things, figure out what the prime factorization of 480 is. It's going to be a lot. It's going to end up having probably 6 or 7, maybe even 8 factors that we're going to have to keep track of. So we don't really want to have to try to do that in our head. So we're going to have two methods. They're basically the same thing, just representing in different ways. So our first method is one that you should be very familiar with from the past, and that is a factor tree. So to make a factor tree, what we're going to do is we're going to take our number, and we're going to write it down. So that's step 1, write the number. It's a very difficult step. Our second step, we're going to take that number, and we're going to break it apart into 2 paired factors, two things that would multiply together to get you back to this number, 480. So you could do 2 times 240. You could do 4 times 120. Anything that works. It's up to you. For me, since I see a 10 at that 480, I'm going to break this up into a 10. Or sorry, so I see a 0 at the end of the 480. I'm going to break this up into a 10 and a 48. So that's step 2. Break into any two paired factors. And step 3 is going to be to just do that same thing, but for these new numbers. And you're just going to kind of keep doing that over and over as long as you can. So our 10, we can now break up into 2 times 5. And those are actually both numbers that we're not going to be able to do anything with. Our 48, we're going to be able to break up into, say, a 6 and an 8. Or you could do 4 and 12 or 3 and 16 or whatever. So we're going to do this again. And we're going to stop once everything we have is prime, which is why it's called prime factorization. So the 2 and the 5, those are already done. Those are prime. Right? Those are good. The 6 we can break up into a 2 and a 3, and so those are both done as well. The 8 is going to get broken up into probably a 2 and a 4, because those are our only options. And then that 4 gets broken up into a 2 and a 2. And so there we are. We have nothing but primes here. Our last step is going to be to take all of these things and to multiply them together, but not actually multiply them, just write a multiplication statement. So we're going to multiply all the prime factors. So what we'd say is 480 equals a bunch of stuff multiplied together. Be really careful here. It's easy to miss factors if you're not paying attention, so you might see that there's a 2 here that's kind of tucked away. So it's not a bad idea to just go through and double check and make sure you've got the ends of every branch that you're going to be including. Also, try to make sure that you're not including things that aren't prime numbers. So I'll see a lot of people who might include 9. 9's definitely not prime. It breaks into a 3 and a 3. And do be careful to make sure you're breaking things down properly. I see a lot of people who will break an 8 into a 4 and a 4. So remember, it's always by division, not by adding. So 480 is going to break down into, if you go through that, 5 2s, and then a 3 and a 5. And now we can take this, and it's not necessary, it's not mandatory, but there will be times it's helpful to condense this a little bit. So we're going to take all those 2s, and we're going to combine them into an exponent. And so this is going to become 2 to the power of 5, and then times 3, and times 5. And there we go. There is our factor tree. So go ahead and try to do this next one for yourself. It's going to be the exact same process. So break it down as best you can. If you need to use a calculator, feel free, write the numbers a little bit bigger. But break it down and see what you come up with. Okay, so we've got 6,552. We want to break this up. I can say for sure it's divisible by 2 because it's an even number. And if I divide that, I'm going to get 3,276. I can tell that that's also divisible by 2. So that's going to get me 1638, which is also divisible by 2, which is going to get me 819, which is not divisible by 2 because it's odd. But it is divisible by 3. A quick trick for you, by the way, if you want to know if something is divisible by 3, if you take its digits, so for 819, if we go 8 plus 1 plus 9, if you add those up, you'll get 18. Since that number, 18, is divisible by 3, that actually means 819 is also divisible by 3. So if you're ever not sure if something's divisible by 3, you can do that. So if we do divide it by 3, we're going to get 273. We're going to divide that by 3 again, and we're going to get 91. That's not divisible by 3, but it is divisible by 7, and that's going to get me 13. And so those are all prime numbers. This was not the nicest tree in the world because the numbers were not all super recognizable. So we'll see a different method that might have worked a little bit better for this one in a sec. So we end up with 6,552 equals a few 2s, a couple of 3s, a 7, and a 13. Or if we condense that a little bit, 2 cubed times 3 squared times 7 times 13. All right. Our second method is the same idea, but a little more structured, a little less free. So it has its advantages and disadvantages in that respect. The nice thing about the tree is that you can kind of break down your number into big chunks right off the get-go. So this one I could break up into a 10 and a 48 instead of having to divide by 2 and then by 2 again. Our next method is going to be really good for cases like this one that we just did, where you don't really know what it's going to work into. But let's start off with an easy one first. So we're going to find the prime factorization of, let's say, 360. So same deal as before. We're going to write down the number. But in this one, you're not going to break it up into anything you want. The idea behind the repeated division is it's pretty much the exact same steps for every person who does it. Everybody does it the same way. So what we want to do is we want to start by dividing it by the smallest prime number we can, which is usually probably going to be either a 2 or a 3. Not always, but most of the time. So we're going to start by dividing this one by 2 because it's an even number. So step 2 is divide by the smallest possible prime number as many times as you can. So you're not just picking random things that are going to divide. You're going to always go with the smallest thing. It doesn't ruin this if you don't go with the smallest thing or if you don't go in order, but it does have to be a prime. So if you start dividing this thing by 10, this whole method is going to fall apart. It will not work. So you got to make sure you're dividing by prime, and it really is preferable that you go sort of in order from smallest to biggest. So if we divide this thing by 2, we're going to get 180. 180 we can also divide by 2 and get 90, which we can also divide by 2 and get 45, which we can't divide by 2. So once you can no longer do a specific prime factor, then you're just going to move to the next one. So in this case, we're going to move to 3. And we're going to stop once we get a prime as our answer. Which will happen pretty soon on this one. So for this, we can now divide it by 3, which is going to get me 15. And we can divide by 3 again, which is going to get me 5. And 5 is a prime number. So there are 2 different ways that some people do this. For me, typically, I'm just going to stop here because I do have a prime number. What some people will do, though, is they will go one step further, and they will now divide by 5 to get 1. And so people will stop once they get 1 at the end. Both are totally valid. It doesn't really make a difference. All that matters is that you remember to multiply all of these prime numbers that you got. So our 360 is 2 times 2 times 2 times 3 times 3 times 5. And same thing, we can condense that. So that's going to be 2 cubed times 3 squared times 5. So I'll give you one more of these to try out. So see if you can do the prime factorization of 12,870. Okay, so 12,870 is divisible by 2 for sure, because it's even. It's going to get me 6,435. Immediately, no more 2s. So now we're going to go to 3. And that'll work. I'm going to get 2,145, which is also divisible by 3, which is going to get me 715. Which is not divisible by 3, but it is divisible by 5, which is going to get me 143. 5 is not going to work, and actually 7 is not even going to work. So we're going to have to skip over 7, and we're going to have to go straight to 11. And that's going to get me 13. So 12,870 is 2. It's a couple of 3s, a 5, an 11, and a 13. And there you are. So that is prime factorization. You got both your methods. it'll be a little bit easier or harder depending on the numbers you deal with, but it is something we're going to do a fair bit of in this chapter. So if you're not 100% sure on it, make sure to go through this again, and you can always reach out for help if you're having a little bit of trouble.